Today I will talk about electrolytic cell, electrolysis, and what is the quantitative aspect of electrolysis. As we have discussed earlier also, uh, electrolytic cell is the one in which electrical energy is converted into chemical energy. So reactions, they are non-spontaneous. So let us see this cell. A solution of electrolyte is there, that is nothing but copper sulfate. So copper rod is dipped in copper sulfate solution, so you are applying voltage. So on applying voltage, now this electrolyte, it will dissociate into Cu plus 2 and SO4 2 minus. Cu plus 2, it will move towards the negative electrode, and SO4 2 minus, it will move towards the positive electrode. So what is happening is Cu plus 2, it will take electron and it will be deposited as copper on the copper rod, which is present over here. That will lose electron and get converted into Cu2 plus. So the electrolyte which is taken, it is either in aqueous state or in the molten state. Now let us discuss about the Faraday's law of electrolysis, in which if W gram of substance is deposited on passing Q coulombs of electricity, then W will be directly proportional to Q, or W will be equal to ZQ. If you see the statement, that is the amount of any substance which is deposited or liberated at any electrode, that will be directly proportional to the quantity of electricity which is passed through the electrolytic solution. Here Z is the constant of proportionality. Now Q is equal to IT if current of 1 ampere is passed. So W will be equal to ZIT, because Q is 1 coulomb and I is 1 ampere. Time is 1 second. So W will be equal to Z. Now Z you can find out, that is electrochemical equivalent of a substance. It is nothing but it is defined as the mass of the substance which is deposited at the electrodes. So when the current of 1 ampere it is passed for 1 second, so Z will be equal to MIT upon NF. Or you can say Z is equal to atomic weight upon NF. Now let us talk about Faraday's second law of electrolysis, in which if we connect cells in series with different electrolytes, it states that when same quantity of electricity is passed through different electrolytic solution which are connected in series, the weight of substance produced at the electrode are directly proportional to their chemical equivalent weight. When same current is passed through copper sulfate and silver nitrate solution which are connected in series, so you can find out what is the weight of copper and silver deposited. The ratio of weight of copper deposited upon silver deposited, that will be equal to the equivalent weight of copper upon equivalent weight of silver. Let us try to solve this problem. 1 Faraday of charge is required for 1 mole of electron change. This is the equation where H plus ions, they are taking electron to give H. Copper ions, they are taking 2 electrons to give you copper, and silver taking 2 electrons to give Al. Now you know 1 Faraday is 96500 coulombs. So Q in this case will be 2F, means 2 into 96500, and Q in this case will be 3F, that is 96500 into 3. Now next equation is a solution of copper sulfate is electrolyzed for 10 minutes with a current of 1.5 amp. Calculate the mass of copper which is deposited at the cathode. So W is equal to ZIT. Z, that can be written as N upon NF into IT. So we'll put the equation. You can write this as M also. So that molecular weight you will take as 63.5 into this is the current, and time you will be taking 10 minutes, mean 10 into 60 upon N is 2 into 96500. So you are getting 0.296 grams. Let us talk about the product of electrolysis. Molten NaCl, that will be NaCl, that is Na plus and Cl minus. So at cathode what will happen is Na will take, Na plus ions will take electron and it will be converted into Na, and at anode chloride ions, they will lose electron and give you chlorine. And these chlorine, they will react with each other to give you Cl2. When we take aqueous NaCl, it will dissociate into Na plus and Cl minus, and even water will dissociate into H plus and OH negative. So at cathode, what will be the reaction which will be occurring is, first I have taken that Na plus, it is taking electron to give you Na, and second is H plus ions, they will take electron to give you H. This H and H, they will give you H2. So E cell of this is minus 2.71 volt and E cell of this is 0 volt. Higher E naught value means more tendency to get oxidized, therefore it is a good reducing agent. Whereas in anode you can see chloride ions, they are losing electron to give you chlorine, and hydroxyl ion, they are losing electron to give you water and O2. Now if you see compare the E cell of this, the lower reduction potential that will deposit. Now you can see that the reduction potential of chlorine is 1.36 volt, and that of hydroxyl ion it is 1.23 volt. Since still here the chlorine, it is liberated as anode due to concentrated solution of NaCl, and secondly due to the over voltage product of electrolysis. So cathode, it is giving you H2, anode is giving you Cl2. So solution will be Na plus and OH negative.